Okay, a quick word on spring force. Spring force is equal to K times the absolute value of X. Now this is fairly simple. K will be either a value they're asking to find or it will be a known quantity. It's the spring constant, and it's the same for each spring has its own individual spring constant. And so most of the time they give this to you. If not, it may be something you have to find. X is the distance the spring is deformed. So let me give you a little bit of help on K. Should be either given or you're going to have to find it. So let's figure out what X is exactly. So let's say that we have this spring here. This is our spring, and this is its normal length. All right. What if we cut it, or not cut it? What if we stretch it? So now we stretch it, and the spring stretches to here. Well, the normal length was to right there, so this distance here would be X. All right. By that same token, what if we were to scrunch it up? So this distance is still normal, okay? But I've scrunched it, so the distance I've scrunched it is X. All right? So either one of those works for finding X. Most of the time that value is given to you. The important thing that you need to know is also that the force acts in the opposite direction. So on this one where I've stretched the spring this way, the force of the spring acts this way. And on this one where I've scrunched the spring this way, the force of the spring acts in the opposite direction. So on this one, the force is going to be pulling it in, and on this one, the force is going to be pulling it out. Okay? Another thing to note is you can't have multiple springs acting at one time, and if that's the case, then you just have multiple forces. All right? But that should give you a really basic overview of spring force. I don't know that there's much else to talk about, honestly. But if you, for instance, let's just say that you have an object. I'll just give you an example real quick. We have an object right here. I think this was one of y'all's problems on the homework. We'll just go over it real quick. And we've stretched it. The spring is stretched a distance of 0.2 meters. And it's got a spring force of 1,000 Newton meters. All right? And let's say this thing has a mass of 3 kilograms, okay? If it asks what is the acceleration of this system, well, there's several things we can assume. First of all, since it didn't mention friction, we can just assume friction probably is not going to come into play. So what we're going to have to do is we're going to have to figure out the sum of the forces on this object. And that's going to be equal to mass times acceleration. So we'll notice that the normal force and the force of gravity kind of cancel out because it's sitting on a horizontal surface, despite the fact that it doesn't look horizontal. We'll just make that, there we go, horizontal surface. And so what we know then is that the only force acting on this that we care about would be the spring force. Okay? So there's the normal force and the force of gravity. Both of those cancel each other out. So we're left with spring force equals mass times acceleration. Spring force is equal to kx, which is equal to mass times acceleration. So 1,000 times 0.2 would be 200, and that would be equal to mass, which is 3, times acceleration. So acceleration would be 200 divided by 3. Okay? Now, I should note, this only occurs for a brief instant. This acceleration only occurs while you're at 0.2. Because once you've gone down a little bit, it's now no longer 0.2. It's whatever that distance is. So like once it gets to 0.1 meters, you now have a force of 100 newtons rather than 200 newtons. Okay? I think that covers it for spring force. All right? Hopefully this helps you. I am signing off now.